This isn't going to be a super technical talk. It's more of a fun display of the way that my brain works when I'm supposed to show off Microsoft services, and I get to build stuff like this to teach you about it. So today I'm going to teach you how to build a little tiny gallery. In addition to, my name is Rachel White, like I said. I'm Oho on Twitter, where I post a lot of bad stuff that I get in trouble for at work. I'm a technical evangelist here at Microsoft, and I'm also co-chair of the Node.js Community Committee. So what the community committee touches is pretty much everything with educational outreach, diversity and inclusivity, internationalization, and a ton more. I'm heading up the internationalization working group, and we always want more volunteers, so if that's something that you're interested in, please talk to me afterwards. I'm also a programmer, an artist, and a maker. I basically have too many hobbies, and I just try and incorporate all of them into the work that I do. So I'm going to tell you a little bit about some of my previous projects that I've done before we get started, so that you can get a better idea of who I am and what I do through my code. So RoboKitty was my first Node.js and first hardware project that I worked on in 2015. For the project, I used a particle photon that was connected to a continuous servo that I glued to the dispenser handle of a cereal dispenser that I bought on Amazon. The way that you activated the sensor was via a Node app on the same network as the photon. You'd basically just go to the website that you had running on your local host and push a button, and you would dispense some food for your pets in case you were too lazy to get up. It was really, really simple. It was the simplest project. It was simple to execute, and I gave a lot of talks on it that detailed with the struggles that you encounter when you're trying to learn something new, and whether it be like a code base or life. I was also extremely verbose with the README so that anybody who wanted to get started with it could, whether or not they knew how to write a line of code. It was pretty successful for being my first open source project. It has over 800 stars. I wouldn't recommend actually using it to feed your pets because there's no tests. The next project that I want to show you is a Twitter bot that I made using stuff at Microsoft. It's not currently online, so don't try it because it's not going to work, but it was up for a little bit, and it is an app that uses Twit, which is a Twitter API client for Node. It makes it really easy for you to make Twitter bots that do anything that you could do with APIs incorporated into, posting messages to Twitter. Although Twitter is going to redo their API soon, and instead of posting and getting, it's going to just be all webhooks. So I don't know how long it's going to be easy, but this bot specifically, whenever people would tweet selfies at it, it would ping the Face API, which is Microsoft's facial recognition API. It returns you an object of XY coordinates for 27 different landmarks on the face, so inner corners of the eyes, outer corner of the eyes, etc. And I did some midpoint math and determined where to overlay a bunch of cute stuff. So I drew a bunch of animal ears and little noses and blushed cheeks, and it would just respond to the people with that cute overlay. I did this project for a couple of reasons. People are super into Twitter bots. There's a really big bot community on Twitter, but there was also people who are really afraid of facial recognition. So I wanted to teach people to understand how some facial recognition works so that they would have the understanding of what exactly it's doing so that they could be a little bit less afraid of it, and also make stuff to get against it if they don't want to do it, because I feel like a lot of the barrier for technology that keeps people from getting into things is fear. So if you help eliminate that fear, then people are more inclined to interact with it and build things. So this is going to get a little weird. The last thing I'm going to tell you about before we get to the important part of today's talk is an art series that I worked on last summer. It was called New Romance, and it's a project that visualized what modern cybernetic augmentation would look like with modern hardware and special effects makeup. So the purpose of the whole series was to partner with underrepresented people who have their own views of what is cyberpunk and what is body autonomy, and help them create a cybernetic version of their future. So this is the first piece in the series, and it deals with the need to be constantly logged on to social media. So the NeoPixel ring is running on an Arduino that has a Node application that is using the Twit API to monitor Twitter for a certain hashtag that I would tell people about whenever I demoed this. And whenever people were talking about the hand, like the lights would change color. So you just get that like kind of notification that, oh, somebody's talking about me, and it's like embedded in your body. And the other cool thing about it is, since it is completely running, JavaScript stuff, a lot of people that incorporate technology that are more just artists tend to use C or C++ with their hardware. So when they found out that I used JavaScript for it, they were like, whoa, cool, I'll have to try that. And I love NodeBots. It's one of my favorite things to do. So that's the kind of stuff that I built. So hopefully it's obvious by those 3 projects what my intentions are when it comes to working on projects that I'm going to release out into the community. I don't necessarily tend to focus on building libraries that people can use in their day-to-day, or I don't even contribute to Node Core, although I have before. I like to pick interesting and engaging projects that take Node and some other cool stuff that people have already built and create a fun story around it. And I like to talk about the mistakes that I've made, because I make a lot of them, and all the things I could have done better, because I think that the whole process is extremely important to me when it comes to humanizing developers as people and not just like code making machines. I gave a keynote at Node Interactive last year that was talking about how creative coding is the best way, in my opinion, to bring new people from other languages or who are totally new to programming, because it's easier for them to relate to something that's tangible and not an actual like business case study when they're unfamiliar with certain technologies. So that's what I like to do. But today we're talking about this. This is my tiny gallery project. This is my old couch that I miss, and Gudetama. Yeah, so I decided to make a little tiny pixel art gallery that you can make, and if you want to keep it in your home. I wanted to utilize some really interesting features of Azure, since I work at Microsoft and they all have free tiers, so it's something that you can build and it won't cost you anything, which is cool. And I also wanted users to be able to upload their own images to be able to display them on the gallery and not just pre-made GIFs that I made. I needed it to be semi-secure, sort of secure. I'm not really great at security stuff, so I wanted it to at least try and protect against like code injection on the upload side. And originally I wanted it to be live pixel art drawing, but I didn't want to deal with Canvas or iterating all over the currently active pixels because I'm lazy. So this is what we ended up doing. So for the hardware back here, I used a Raspberry Pi 3 Model B. I'd only worked with the Pi once previously because I was intimidated with the older models with having to hook it into the router because I'm needing like a display because I'm lazy. A lot of my work is motivated by the easier way to do things. Luckily, I found this really great library called Pigallery, which allows you to provision everything for your operating system without having to like SSH in beforehand. So it'll let you pick if you want a light version of Raspbian, and it lets you put your Wi-Fi password in, and it lets you set up VNC viewer, so you can like get it up and running right out of the box if it's on your Wi-Fi network. It's fantastic. The other hardware that we're using is a 32 by 32 LED matrix pixel or panel. I got mine from Adafruit, but you can get them from anywhere that sells hardware. They're all pretty standard. And these can be daisy chained into larger panels, which is really cool too. Luckily for this whole thing, the hardware part is actually the easiest part, mostly. I mean, for me, you may not feel the same way. The panel itself only requires a 5-volt power supply, which is the only soldering that you have to do for the whole thing, which is this down here. It's just soldering your power and ground wires onto a 5-volt barrel plug. And then from there, it's just matching wires from the Raspberry Pi onto the LED matrix. And for powering the LEDs, a single chain needs 13 input-output lines, and it fits neatly onto the header of the old Raspberry Pis. The new Raspberry Pis, which this one is, has 40 pins, so it allows you more GPIO. So you can have actually 3 parallel chains of these hooked up, but we're just dealing with one. So we're going to start with talking about the application that's running on the Raspberry Pi. It's Node.js, since that's usually what I write. It's also a testament to why I shouldn't be allowed to write production code and why I switched from software engineering to evangelism. I would definitely be responsible for a lot of the IoT botnet stuff if this was my full-time job. So I really just love to write fun, lazy code that gets the job done. And since the Raspberry Pi is the one that's going to be powering the matrix, we have to write some stuff to run the panel, but there was a problem with that. There was no node library for the LED matrix. There is one, but it isn't maintained and it wasn't working. So I got a little messy with it. And I'm using a C++ library and making calls to it from the shell using a package called nodecmd. So I'm just running from a Node application command line stuff to send it over to the Pi. So it's not the cleanest, but it works. And since the way that I'm handling the files from the website and passing them to the Raspberry Pi makes me comfortable enough for it to be messy like that, since a lot of the things from Microsoft's IoT Hub take it so that your file names are, there's like a UID, so it's going to be generic and people can't really, do some code injection type things. It was fun to figure out, although when I tell people what I did, they're kind of like, why? Why did you do that? But it works. And then the web app, it's a Node.js web application. I'm using Express for the routing, Socket.io for the real-time communications, and jQuery because nobody tells me what to do, and EJS for the templating. There's a little bit more going on under the hood, but we'll talk about that when we get to the code, which I will show you. Please don't judge me too harshly. Another huge part of the project is reliant on some Azure services that I mentioned before. We're going to be using IoT Hub, File Service, and Web Apps. So the IoT Hub is really cool because it allows for communication between the web app and the Raspberry Pi. When an image is selected from the web gallery, it pings the IoT Hub, which notifies the Raspberry Pi that there's an image ready to pull down from the storage and display. And the IoT Hub allows you to have bi-directional communication between devices. But the best part about it is that there's per device credentials. So it is authenticated and it knows, like the hub knows when it's getting messages from the correct site to the correct device. So it's like hard to do injection from anywhere, really. And the other thing that's good about it is that the Azure portal helps out immensely with metrics visualizations. So I'm able to see if I'm having any kind of communication errors really, really quickly. And the free tier has up to 8,000 messages a day, which is way more than enough for like the hobby projects like this that I'm going to be showing you. And then Azure File Storage is what we're using for all of the pixel art. It is simple, secure, fully managed cloud file shares. It is server message block and HTTPS, and it supports different kinds of shares based on your needs. Specifically today, we're using blob storage since we have unstructured data and it's all just images. Plus there's a Node SDK for interacting with the storage, which made my life a lot easier. And finally, we're hosting the site on Azure's web app service. The best part of it is that it eases the integration for continuous deployment with your site. If you have it on GitHub, you're able to authenticate into Azure, and every time you push, it just automatically rebuilds it. So it's really easy to update your site without having to worry about, necessarily having an up-to-date code base if you can just pull it down from GitHub on any machine and fix it. It's really nice, it's really quick. It also has built-in application insights so that I'm able to see if there's any like bad calls. It tells me immediately, which is cool. And the free tier is also really good. It has 10 apps and 1 gig of disk space. So now I'm gonna show you the fun code and demo time, which we'll see. We'll see how fun this is. I will show you the app first. I'm not mirrored, so give me 1 second. I'm gonna see if I can mirror it instead. Yay, okay. Keep changes, great. I'll make it bigger as well. So this is the messy. I don't refactor my code. I mean, I don't refactor it because then I get to just show you like what my stuff looks like, and plus it's not production. Let me exit out of here. So using a ton of different packages to interact with things, the IoT hub, IoT common, having some process variables for my environment variables and stuff, and then your standard node stuff for your files, Express, Node, Socket.io, Molter to handle multi-part form stuff. And then let's just scroll down here. All I'm doing is, setting my view engine with EJS, using public for my Express site. So, the whole entire site lives in here, except for index.html that's at my top level. And what it does is it listens for the load on the first site, which I'll show you the site. It's very simple, very cute. When the site first loads, it connects up to the file server, and it has all of these little GIFs that I had already uploaded previously, and the EJS template pulls them down and populates it down there, so I don't have to hard code any images in, which is really nice as well. And sorry, my computer's kind of slow. This is the IoT client for the IoT hub, so it knows when Socket.io is telling it that certain things are happening on the front end. The back end pings the IoT client, and then the IoT client sends it over to the Raspberry Pi, which is also listening for those messages to come in. And then we're just doing regular app.post upload to handle the blob service uploading of the gallery icons. One thing that I'm doing is while it gets, it has a name that's being generated on the file server side. You'll see in a second when I show you the Raspberry Pi code. And then, I like to tell them that you're doing great, because that always feels good to see nice messages instead of errors. So that's pretty much what the web app is. The Pi app is it's a little worse. So let me open this up. Okay, I'm gonna close this down. So the way that it lives is it has, here's my Raspberry Pi. I'm connected to it with VNC Viewer. I have a matrix folder that has my C++ library for all of the Raspberry Pi RGB LED matrices that I'm calling from inside Node Pi. Sometimes this doesn't let me click it. There we go. So you come in here, let's open this up and peek at it. So this one is the messier one. It's using the same IoT device stuff that the Node web app is utilizing. I have an image downloader package because I'm lazy and it downloads it for me. I don't have to deal with FS that much. And then Node CMD is what runs it on the command line. So as soon as you're connected in here, which I don't have any automated scripts that run this code as soon as the Pi starts up, which would be easy to do. I just didn't do it yet. I have to just get in here and run node index.js. But basically, I am saving every single file as active image, so I don't have to, worry about what the actual name of the file is called. And then I just delete it after it's displayed every time, so that if anybody tries to upload images that are way too big or way too many from the front end, the Raspberry Pi cleans it up every time. So then here's the messiest part. I just run pseudo Raspberry Pi LED matrix with the code that you would run to display it without using Node. So that's how it works. And now I'll show you. It'll say connected. Great. Okay, so client's connected. Are you connected? You are. And then, so down here I have all my little images that I've made. Let's see if it works. Yay! So yeah, there's the little donut and the spaceship. Did the spaceship work? Yeah. And the TV. And the gradient. And like I'm connected to a little like portable MiFi thing, so it's pretty good with the like connection. There's not a lot of lag, which is fun. And I know that like I've seen people that have built DIY gallery type things for their homes that are like TVs and really elaborate and stuff, but I figured that this was just like a fun, cute way to build stuff like that. So I never remember how to show things from the current slide. Where is it? Slideshow. From current slide. Even though you can see it and you know that it's the end. And of course, okay. Yeah, so that's my little LED gallery thing. My name's Rachel White. I'm Oho on Twitter. That is the code for the Pigallery. And talk to me if you're interested in being a part of the community committee for Node.js. Thanks. Does anybody have any questions? You can ask me anything, even if it's not about code. I like questions. No? Okay, cool. Okay.
I'm curious, so you had like an Arduino before, and now you're doing the Raspberry Pi. Did you just want to try out the Raspberry Pi?
I like to try every single microcontroller that I can like feasibly understand. So like I also have some of the teensies and the trinkets and the flora and the wearables and stuff like that. There's as long as there's a certain, well, for the Arduino flavored boards, like there's a bunch of stuff being done so that you can write Node on it, even if it's not, because like, well, the difference, you know the difference, I'll say the difference. So with the Arduino, the code that you write on it lives on your computer and gets executed on your computer. With the Raspberry Pi is its own contained operating system, so the code that you're running is running on the Raspberry Pi. So it's two totally different types of things, even though they both technically fall into the realm of microcontroller. But the interesting thing is that you can also write code to live on a Raspberry Pi that executes to an Arduino so that they're hooked up if you want it to be like decoupled from your actual machine, which is neat. I just like am really interested in the weird ways that you can hook up the hardware. Anybody else? No? Okay, good. Thanks.
Awesome. So yeah, that's all we got for tonight. Thank you guys for coming out. Thank you to the speakers again. Really appreciate it. Yeah, feel free